Everyone, so today I'm going to be going over how to find trig functions for any angle other than the special angles that are in the unit circle. So to start off, I want to remind you of the equation of a circle that's centered at the origin, so 0, 0, that has a radius of r. So from your geometry class, you may remember that that equation would be x squared plus y squared equals r squared. Okay, so let's suppose that we have a point on the coordinate, here we go, like this, on a circle, okay, and the point P has the coordinate x, y. Okay, so that's the point P. And we know that the radius is r, okay? So if theta is an angle in standard position with a ray of OP, and we'll say it's circle O, and is in quadrant 1, well, then that's theta right here. That's our reference angle. All right, so how could we express sine theta and cosine theta? Okay, well, we could drop an altitude here. We know that this segment here would be x, and this segment here would be y. So if I wanted the sine of theta, I would do opposite, so y over r. And if I wanted cosine theta, I would do adjacent over hypotenuse, so x over r. So we can use this idea on any point on a circle. It doesn't have to just be a special angle. We found the special angles using this method, but those angles come up all the time, so we're going to know those ratios. But not every circle is going to have one of those special angles. So here's an example. If the terminal ray of an angle passes through the point negative 512, and find sine theta and cosine theta. So in this case, I said you must sketch a graph first as part of the solving, but not necessarily, so we're going to look at other ways as well. But for this one, let's draw it. So here I'm going to draw a circle centered at the origin, like that, right? And so not a great circle because it's not symmetrical, and it should be negative 512 would be right about there. And I'm going to start in standard position, and I'm going to go all the way to that point. And so this is that's my terminal side. Okay, so if I want to find sine, I'm going to need to find the reference angle. Now remember, the reference angle is the angle created with the x-axis, the acute angle created with the x-axis. So I'm going to drop an altitude and create a right triangle. So I know that this length here would then be 5, and the hypotenuse, and the y value would be 12. So first I'm going to find the third side by using the Pythagorean theorem. Now, some of you may remember it is a 5, 12, 13 Pythagorean triple. Great one to know, but you don't have to know it because you can always use our friend Pythagoras and find r, okay? All right, so we get 25 plus 144 gives me 169, and so that's where that 13 comes from. So now if I want sine theta, I'm going to do 12 over 13. That's the ratio, and my cosine ratio for theta would be 5 over 13. Now, remember, you could do just x over r as well. You don't necessarily have to draw it. All right, let's revisit one of the fundamental identities that we talked about. A couple days ago, we talked, you guys actually investigated, and you found that when you found sine squared theta and you added it to cosine squared theta, you always got the number 1. That's also something you could use. For example, in this case, when we found that sine theta was 12 over 13, we could plug 12 over 13 in for sine squared theta, and we could square it, and we could solve for cosine squared theta. So that's something that we could do as well if we wanted to. All right, let's try another example, okay? All right, so in this case, it says theta is a 4th quadrant angle and cosine theta is 3/5. Find sine theta. So we're going to look at two methods. We're going to look at the circle method. We know that theta is in the 4th quadrant. So that means that my terminal side is in the 4th quadrant. So if I put, my circles are terrible today, guys, sorry. So if I'm going to draw my triangle, remember we always draw our triangles, so they create a bow tie. Theta is always that inside of that bow tie. So I know cosine theta is 3/5. So cosine is adjacent over hypotenuse. So I have to find the third side of the triangle, which would be 4. It's a 3, 4, 5 Pythagorean triple, but you could use the Pythagorean theorem to find that. And so if I wanted to find the sine of theta, what I have to remember, though, is that sine is negative in the fourth quadrant. So that, yes, it's 4/5 opposite, but it's also negative. So sometimes kids will actually put the negative next to it. We know that that side length of a triangle can't be negative, but so they don't forget, you might sometimes do that. So that's the visual way, the way I just showed you how to do it. Find the point, draw a triangle, find the ratio. Another way is to use sine squared theta plus cosine squared theta equals 1. So let's see what happens. So sine squared theta plus cosine squared theta equals 1. Well, if cosine is 3/5, well then cosine squared would be 3/5 squared. So let's see what happens. So 3/5 squared is 9 over 25. I'm going to subtract 9 over 25 from both sides. So that's going to give me 25 over 25, which gives me 16 over 25. And so if I have sine squared theta, let me get some more room here, equals 16 over 25. We've never done this before, but it's a square. We can actually take the square root of both sides. So sine theta would be equal to, now you do have to remember it would be both plus or minus 4/5, but because I'm looking in the fourth quadrant, it would have to be the negative 4/5. Okay? All right, so that's 2 ways that you can solve for angles that are non-special angles in a circle. All right, hopefully that was a helpful video. Have a great day.